Okay, I've got a question here in the chat. Can changing between model view principal and MVC be as simple as dividing the view to view controller and vice versa? Yes, more or less at least. In the model view principle, the view is the whole entirety of the user interface. And depending on exactly how you do this, it could be more or less easy to divide it into a view and controller type of architecture instead. Actually, this will be exactly what we will be doing right now. We will be taking our implementation of the dice game, that is model and view, and we will make it a model view controller architecture instead. And I will also share the screen now. So, well, you should recognize this code by now. It's nothing actually changed. We have this console view here that, well, maybe does a lot of things. In our case, maybe it, well, it ain't that big, but this is a simple example. Dice and dice game are exactly as they were before. So, to change this to model view controller instead, we create the, need to add the controller. And in Java, I do this as a package. And we should add a new file here. I elect to call it player, as this is kind of like the actor name for the one that drives this scenario. So let's open it. And let's add the operation play game, as this is what you actually would like to do. And as we saw in the structure, we, if we can find the structure here again, the basic structure. So we have added this package. Now we probably need some kind of dependency to the model and some kind of dependency to a view, because, well, the controller should execute something in the model. In our case, call play on the dice game, and it should do tell the view to do something, display these messages, and collect the input from the user. So let's try to do that. And I think that we will just take the code here in play game to start with, at least. Remove it from the view and add it to the controller instead. So we can maybe just copy paste like that. So first we have the system out print line. Hello dice game world, and any key to play, Q to quit. And this is clearly something that has to do directly with the user interface. We have this, the usage of the system out. This is like the API that we use. So let's move this to the view instead. Let's go up here, and we could also imagine that we actually need a view, so we can use it. So instead of directly outputting stuff here, we call the view and tell the view to do it. Something like that. The same thing for this display, and we can see that we have this down here also. So let's move that one. Something like that. All right, we just call this one a view. Something like that. Possibly it's private, so let's make it public. So as long as we don't quit, we want to play, and this is as it should be, and then we need to do some kind of like call some status or something like that on view instead. Something like that, I believe could be the thing to do. So, all right, we need to start the game in a slightly different way. We don't have the user interface here. Let's call it view instead, and we have all right, time for some compilation.
It says welcome message.
Oh, I think this is a little bit better though. Results maybe? Yeah, I think we should have Let's run it. So, looks like before. Hopefully it plays like before. Oh, I quit. A lot of duplicates. Ah, I won. All right. So, we removed all the system out and system in from the controller and put it inside the view instead. And the view in this case actually has no dependencies on the model. So that's a little bit interesting. This is of course a very simple case, and it is not, well, very likely that it is this easy to achieve a passive view, so to speak, where you have no dependencies on any model data. And we have the controller. I named it player after the actor. Maybe we should have some indentation here also. It looks a little bit ugly. And here you can kind of like actually see exactly how this scenario spells out. First we display a welcome message, then we display some instructions, then we get some input from the user interface, then we play the game and we display the results, and then we display these instructions again. So we kind of like have this loop of interaction. And I actually just wrote down a quick use case for this simple requirement. So you have the requirement name, play game, you have the actor player, and this scenario starts when the user wants to play the dice game. So he runs the program, that is that step. And then number 2, a welcome message and instructions are displayed. Yeah. The player selects to play. This is the main success scenario, so quitting directly is maybe not the most common case. So, and then we display the results of the rolls, and if the sum is 7, the player wins. And we repeat from step 2 as long as the player does not quit. So basically this is more or less exactly what you see in the controller in this case. So you have some output, you have some input, you have some output, you have some input, and this drives the scenario. So we have some output, we have some input, we have some output, we have some input, and we even have this loop actually in the controller. So there is something that is bad about this implementation. I don't know if you can spot it. Let's try something then. So one of the advantages in Model View Controller is that you should be able to add the new user interfaces. We will simulate this by adding a Swedish language console class here. And to tie things together, we will also add an interface for this view. I call it iView. So, oh, I don't think you can do that. We'll open these files also. Package view interface iView. The I is just a naming convention from my point of view. This is something I like, so don't read too much into that. So we could just actually take the operation signatures from the current console here. And just put them inside the interface. So we specify the interface. So, I think that should do it. Sweet. Yeah. So the controller should now, of course, not work directly with the console, but rather with the interface. Because we know that any object that fulfills this interface has these operations implemented in some way. And we can change this way. So, okay, let's just make some kind of like quick translation here. I think the Swedish characters actually don't display that well, so we can try it. Vad ska vi ta? Let's take A. So basically we have made a quick translation here. It's, well, maybe not the most elaborate example that you can imagine, but it's simple at least, so maybe we can compile. Oh. So we have the English version. And if we change to a Swedish console, everything should run okay. Wasn't it Swede console? So, and if we run it, yeah, we had good characters actually. So, okay, we play, you just press some key. And if we want to quit, we should press A. But that doesn't work. And exactly as we have someone stated here in the chat, this Q character is maybe not correct, because you need to change now in the controller here. Oh, it should be A, because this happens to be the Swedish console implementation. And this now kind of like destroys our whole intent with having replaceable views, because even if we change the view, we need to change the controller. So they are dependent, but this dependency is quite hidden or not that obvious. So we can't have it like this, of course. So instead of having this code public and in the interface, we should just like have something like this instead. This should be A in the Swedish. And it should be Q in the other one. And instead we ask the view wants to play. Ah. I'm actually used to that, so let's run it, and A to quit, and it's quit. And if we change back to the ordinary console, run it, compile, run, you should have Q to quit. So now it works. And this is a type of dependency that can be really, really hard to spot. And we could see it if we took a look on the output string here. It says that you should press Q to quit. And before we had this information, the Q character actually also in the controller. So they were dependent on each other, but in a very, very subtle and hidden way. And this is typical for having this kind of string dependencies. You kind of like have them, but you don't see them. So they are really, really bad. So watch out for this type of problem. And the test is, of course, can I implement a new kind of view and just run it through the same type of controller? So by moving this even closer, in the Swedish one we had A and we had A here. You could make this, of course, more elaborate to have it as a variable or something like that, but this serves as an example, and sometimes it's not that easy to do this kinds of stuff. So, any questions? Was it super clear what we did? And this actually, I think, suits the scenario also much better. Repeat from step 2 as long as the player does not quit or wants to play. Could be a better wording of that scenario. So in the controller you can quite easily just see what happens in the application. At least that's the general idea. All right, this will of course be posted to the GitHub repository of the course, and you can check the code out to play with it, add your own view. I don't know how familiar you are with interfaces, so read up on that if you are not that comfortable with it. The next step in our application is that we would like to do this, make this a little bit more exciting. It needs to become more exciting, this game. So I will just make some copy, and we should kind of like project, open this one. I will rename it first. Some other kind of naming standard here also. So we have the exact same project here. It runs as before. Oh no, it did not, because I was in the wrong. I don't get it. So, okay. Quit. But to make things more exciting in this game, I'm actually adding a delay here between the first dice is rolled and the second dice is rolled. So yeah, I just sleep this thread. And this is to simulate that, well, first you roll one dice, and you check the result, and it's a 5. And then you roll the other dice, and you really, really want it to be a 2, so that you get the 7 and you win. And this will make this game a whole lot more exciting. So we could achieve this by just rolling the first one, pausing the application, rolling the second one. So let's try it and see what happens. So we run it, we don't quit, we play. This was not exactly what we wanted, because now it just takes a long time, and then we get the both of the results. Okay, so not more exciting. So we need some way of showing the result here. So let's do that then. Let's just print it. All right, let's play. First dice, maybe. No. Something did not work out as I thought it would. Ah. Need to move this here, of course. So now we play 2, 5. No. 2. No. So you see, it became much, much more exciting, the game. However, while this compiles, works, does what it should, we have kind of like broken our architecture. So we're not allowed to do this. So what should we do? What should we do? We need some way of telling the user interface that, okay, a dice has been rolled and it had this value and you should now display it. But we cannot make any calls directly from the model, the dice game, to something in the user interface, because that would violate the architecture. How should it be solved? Yes, but that is also part of the user interface. So unfortunately, that is not legal to do either. So no arrows pointing from model to controller, no arrows pointing from model to view. So nice try, but no cookie. Yeah, we could put the timer inside the view instead. That would be a solution. But let's imagine that this is not possible for some reason, especially for me to make a pedagogical point. But you could imagine you have some complexity in this this rule of waiting, and you could also say that well, the waiting time it's part of the rules of the game, and well, you should not put business rules inside the user interface. We have one option here, to different methods to play. Our method produces the result instantly. Yeah, you could kind of like break up the play operation and call roll, maybe roll dice 1 from the controller, roll dice 2 from the controller. But this would also kind of like put a little bit of the business rules inside the controller instead. And well, as some of you may have noticed, or well, observer pattern to the rescue. And the problem that the observer pattern would like to solve is we would like to send a message from one object to another without a direct coupling. So without coupling dice game directly to the console or to the view, we would like to notify these that, okay, I rolled the dice now. You can do something, whatever it is you want to do. And the solution is to reverse the dependency by letting the sending object, often called the publisher, manage client object, often called subscribers, using an interface. And the structure looks something like this. So you have a publisher. To the publisher, you can add subscribers, and you can remove subscribers. And more importantly, on some event, you notify all the observers or subscribers that have been added. You have an interface that has some events in it, and you have subscribers that fulfill this interface and implement some event in their own way. So, okay, let's do that then. Who should be the publisher in our case? Who would like to publish an event? Is it the view that rolls the dice? No. It's not. No. Yeah. Exactly. We have a model publishes events and view subscribes to these events, or something in the user interface. Could be either view or controllers. So in our case, we have the dice game. If you look at it, well, this is exactly what we would like to notify about. I roll the dice, this is the value. So it's maybe now more clear that the dice game is the publisher. I publish dice rolled events. And this means that the interface should be added where? We have a direct dependency, often in the form of some list or some array of these observers inside the publisher. The publisher in our case was the dice game. So we have an arrow, a dependency from an association from dice game to this interface. And this means that this interface must be in what package? Model, exactly, because we can't have any arrows going either to controller or to view. So let's do that. We have quite a little time, but I think we can manage if I manage to manage all my windows. Let's add it. Let's open it. Really hope that this will work out. So we have a list. Package name, good. Kanske, maybe. Okay, anyone good in Java? utils. Utils that not two L's. That can't be it. Oh. Yay, good. Great. So we have the interface. Let's just do this instead here. Can you do this in Java? Yay, thank you. So we roll the first dice. We call all the observers with this. We should do the same thing, of course, when we have rolled the second dice. We remove this. And we have some code duplication going on here, but we will worry about that later. And we will change that one also to this. Compile. So, and then we need someone to implement the interface, and we can select either the controller or somewhere in the view. In this case, I select to do it in the controller based on two things. First, we need to we had the passive view. So if we add let the views implement the interface, observer interface, we would add a dependency from the view to the model, and we have managed to steer clear from that so far. So it could be a good thing to continue to avoid this. And also we have two implementations in the view already, and it would be a little bit messier to add the this to the views. So this becomes the subscriber. And it needs to do something. We have the needs to implement this. Needs to do something. Let's just display it for now. Something like that, maybe. Let's compile. Oh, All right. And we also need to actually add ourselves. Was that the name? Add subscriber, yes. And I would like to add myself as a subscriber. So hopefully everything should work out now. Three. Also I won, so let's quit. So we could now manage to do this exactly as we wanted, using the observer pattern, and let the dice game be the publisher to publish events that its dices has been rolled, and this is then sent to whoever wants to listen. And this one needs to implement this function, dice rolled. Bad big D there. But and we put this in the controller, and the controller now displays this. Of course, this should be moved to the view. You should not have the system.out.println there. But time is running out here, so I will do that later on and add it to the GitHub repo instead. And we will see what happens. So I will give you some homework for the next lecture, and that is to create a class diagram for this new application. And we will take a look at it, what it actually looks like next week. So go through the classes, go through the dependencies, try to find all the relationships that exist. Try to manage what is a, how do we model interfaces in UML? How do we show that this class implements an interface? How do we manage associations? What's the difference between associations and dependency? And sort these things out and do your best, and we will take a look at it next week. Any questions? Good. This was kind of like super fast, so I understand if you need to review this maybe at your own pace. And please check the code out, make some experimentations and stuff with it. I will add it this afternoon to the GitHub repo. So hopefully you will get a better understanding on your own also. A question here. Generally, should class diagrams be made before or after implementation? I don't think there is an easy answer to that question either, because you can have different kinds of, that it depends on what you would like to do with your diagram. I think that making diagrams before you implement is good if you need to coordinate several different developers. We need to do something together, and then later on the parts should fit. Then you need to do something at least to some level of detail before working separately. Doing class diagrams after you have implemented shows what the design actually looks like based on the implementation. So you can have some discrepancy there, of course. So if you do a diagram before, you implement, you do a diagram after, and you can check, did we do it as we said we should do it? Or have we added something that is not good? Have we maybe made some improvements? Some things that we did not think of when doing the diagram beforehand? So I think the two ways kind of like complement each other. They are not, you should always do diagrams first, or you should never do diagrams first. They are tools just like anything else, and you can use them in different situations, and they have different advantages and drawbacks. However, I would not possibly recommend doing a very detailed, large-scale blueprint over a software system up front, because it will take a lot of time and it will be very, very hard. But at the same time, if you are like 10, 15 people working on this software, you need some way to communicate and to make things fit together. So you need to find a balance there. Okay, yeah, the question about the peer review. You do the peer review in the same group that you worked in. So you don't, if you are 3 people in the group, you don't need to make separate peer reviews, but rather you gather in your group, you read through the materials, and you discuss and come to a consensus regarding the feedback you send to the other groups. Yeah, we have interaction diagrams also. We did this, I think, the first lecture. We will take some better looks at it in future lectures. I also, he has the notation and stuff like that in the book, so you could also look it up. Have some more questions going on here. Multiple attendees are typing. No, you don't need to use model view controller in workshop 2. It's sufficient to have model view separation. If you would like to do model view controller, you can achieve model view separation by using this pattern. Okay, Henry, you can send me an email so we can sort things out. All right, I think that is it for today.